In this video, we will be looking at prison break problem and we will be building a solution in JavaScript and compute the time complexity and space complexity of the solution that we will be building. Before jumping into the solution aspect of it, let us first try to understand what this problem statement is. The problem says that we have a prisoner who is trapped behind a prison doors, and this door has bars like this vertically, and these are iron bars, and there are also iron bars horizontally, and this door is represented as a matrix as a input of a problem statement, and we get n m h v, wherein n and m are basically number of rows and number of columns, and h is an array of the horizontal bars that are going to be removed when the prisoner is trying to escape. So when the prisoner wants to escape, the rods which are here, they are going to be removed by the prisoner, and once the prisoner creates a big enough hole, the prisoner will be escaping. So the end goal is here that the prisoner is escaping. After escaping, we have to find what was the maximum hole area that was created after the prisoner escaped. And this basically is a problem statement. And now we can try to find the best suited approach to reach a solution. Let's assume that this is a highest gap that is created, which is 4, represented by, if this is 1 in this grid, we have 4 grids here giving us a maximum area of 4. Now we assume that this is our biggest area from this example. Now let's try to make some observations from this. What makes it the biggest hole in this matrix? Let's just try to look at it from horizontal perspective first. So let's say we are just trying to look at it from horizontal perspective, and we know that this is the space which is available horizontally after this horizontal bar 2 was removed, which is provided as an input to us. Now when we look at this, we can observe that there exists a gap. So there is this gap here that exists after one bar was removed, and this gap was the gap we decided to choose to find the maximum area. Now let's dive a bit deeper and try to figure out why only this gap and why not this gap. So we had a gap here also that was there, and we had a gap here also, but why just this horizontal gap that we had? The reason was simple enough, that this was the maximum gap that existed. That's why we took this gap into consideration. And similarly, if I look at it from vertical perspective, let's just say that I want to now take a look at it from the vertical perspective. So this bar is there, we removed this bar, and this bar exists. So we had this vertical space here, and in this space we decided to choose this gap that we had created, this gap, and we decided to skip this gap, and we decided to skip this gap that existed vertically. Why did we choose just this gap and we decided to skip these 2 gaps? The reason is simple enough, that in the gap that was created here, the area is higher compared to the gap that exists here, or the gap that exists here. This was the highest gap that existed vertically. Now, after having said that, what is the first thing that comes to our mind? We said that horizontally we picked up the highest gap, and vertically also we picked up the highest gap. And what did we do with this gap? So we took a gap here which was 2, and we took a gap here which was also 2. And if we just do multiplication of this 2, so 2 into 2, this gives us 4, which is the whole area that we are looking for. And to translate this into simpler words, what I could have said is, find the maximum horizontal gap, find the maximum vertical gap, and just multiply these two. This is the core foundation of our solution. Now, moving ahead, is this going to be enough to reach our solution? Are there any other constraints that we have to look into before we try to jump into writing the code aspect for this? Let us say you have a matrix something like this. Looks like this, looks like this, and let's put one more bar here. And for the prisoner to escape, the prisoner has size something like this, let's say. So the size of prisoner needs this 3 blocks to escape. And I will say that I will only remove this bar that is on the end here, and I will remove this bar that is on the end here. Now, will the prisoner be able to escape? This 2 now becomes 2, this 2, and this is 1. So even though I removed bars, I was still not able to escape in this case. Now, what went wrong? Why was the prisoner not able to escape even after removing bars? So what this highlights to us is that when you remove these bars, let's say I removed this bar and I removed this bar. Now will the prisoner be able to escape? Yes, now the prisoner will be able to escape. Now what did we observe here? We removed the same set of bars earlier also and now also. But the difference was that we now removed bars consecutively. The gap that was required was only created when the bars were removed consecutively. If you leave a bar in between and just remove the edge bars, the prisoner will still not be able to escape, because the largest gap will be only formed if you remove bars consecutively. Because simple enough that if this had existed, then the space that would have been created is 2 and 1, which is not enough for the prisoner to escape. And having said that, this gives us a next tip that we will be using to solve our problem statement. That when these bars are removed, we have to remove these bars consecutively, and it has to be the longest sequence. Why the longest sequence? Because we want to find the maximum whole area, and to find the maximum whole area, here what we did was we used the maximum gap horizontally and we use the maximum gap when the vertical bars was removed. So this gap was created when the horizontal bars were removed, and this gap was created when the vertical bars was removed. So we used maximum of both these gaps and then we reached our solution. And let's build on top of this now. So we said we have two parts. One part is finding the maximum horizontal gap, finding the maximum vertical gap, just multiplying it. And when we try to find this gap, we have to ensure that in this gap the bars are removed consecutively and not randomly. And the input we receive is not going to be sorted input, it's going to be unsorted input in this problem statement. So we can now split this into two parts. First part is finding this longest consecutive sequence from these bars that are removed, and second part is then just multiplying the output that we get of the gap that is created from this sequence. So let's say we have 1, 2, 3, 4, 5, 6, and we say in our input array we have 3, 4 and 5. We removed this 3 bars consecutively. What will happen is when 3 bars are removed, the gap that creates is between this two, between this two, between this two, and between these two. So if you removed 3 bars, the gap was 1, 2, 3, 4. So the sequence plus 1 is a gap and not the sequence itself. As you saw here, if we remove this one, and this one, then because there was a gap that existed between these two also and this two also, it gets accounted for the entire gap. So this is 1, 2, 3 and 4, and that's a gap. So we will just have to find the sequence which is consecutive and the longest one and just add 1 to it to reach our solution. This is good enough for us to now start going into the coding aspect of it, and let's proceed ahead. So what we said was we want to find the longest consecutive sequence. We will just give input to our problem statement as either the horizontal bars removed array or the vertical bars removed array, and then we need to return the number of elements in the sequence. What I mean by this is, in this sequence we removed 3, 4 and 5, and this were removed consecutively. So we will remove this and then we will just return a sequence which is the longest sequence in this specific input if this was our input, and then just add 1 to it. So what we will say here is, let maximum horizontal gap be. You will find the longest consecutive sequence by passing the horizontal bars that are removed. Just add 1 to it. Let the max vertical gap be. Find the longest sequence for the vertical bars, and the sequence has to be consecutive, and just add 1 to it. Why we add 1 to it? Because the sequence plus 1 will give us the gap that gets created. That's why we add 1 to it. And in the end, what we will do is just return this multiplied by the maximum vertical gap. This is the initial foundation that we laid here, saying just find the max horizontal gap and then find the max vertical gap and just multiply it. And for this gap you have to find that this bars are removed. Laid the foundation and we are good to proceed ahead. Let's build the logic of finding the longest consecutive sequence. to find the longest consecutive sequence, what we will have to keep in mind is, let's say we have 3, we have 4, we have 5. What made this a consecutive sequence? Let's say this was a current number. We could say that this two are consecutive sequence because to the current number, if I add 1, I get 4. And then to this 4, if I add 1, I get 5. The logic being built such that if you keep adding 1 to your current number and that next number, which is 4 in this case, existed in your input, wherein you try to find the consecutive sequence of the bars that were removed, we could say that yes, this is consecutive. And similarly, then we started the sequence here and we just kept going, just kept incrementing till this condition was being met, that the current number plus 1 gives you the next number, and then this next number is there in your array that you have received as input. And if you have 9, let's say, once you reach here, you will say 5 plus 1, which is 6. 6 is not there in your array. So now the sequence breaks, and this is your sequence that is left with having 1, 2, 3, 3 elements in the sequence. And we will just build logic around what we just now said. And to do this, what we will do is we will just pick elements. So I will pick one element, I will traverse the entire array and try to find this sequence that satisfies current plus 1, giving you the next element of the sequence itself. And to do that, what we will do is something like this. I will use a tracker set and I will just say give me a new set of my input elements. I will track all these elements in my set uniquely. I will just use a loop tracker and I will keep iterating through all my elements that I have, and I will say that while some condition gets satisfied, and that some condition being that current plus 1, whatever element we get next has to be in my input array to call it a consecutive sequence, which translates into code as something like this. While tracker set has the next element, what is going to be my next element is my current element plus 1, and that is going to be something like this. So I will say let current number be my nums of I, and I will just say while we have current plus 1 in your set, basically whatever was there in the set we put in this tracker set, and it exists uniquely with a lookup of time complexity big O of 1. And if it exists in that set, we need to just keep incrementing our sequence counter, because we said that hey, if current plus 1, which was 4, was there in your array, that means there was a sequence. First I started with just one element, so let's say the sequence was 1, then I found another element, then the sequence became 2, then the sequence became 3, and then the condition was no longer being set, and this is what we were left with for the sequence counter. So we need some kind of sequence counter, and to do that, what we can just do is, let's say current consecutive sequence is 1. Why 1? Because when we are in this array and we are looping through the elements, you have at least one element which is your current element. That's why the sequence starts with 1. And if you're able to find the next element, which is current plus 1, what we can do is just keep incrementing a sequence. After we increment a sequence, what we did here was 3 plus 1 we got 4. Then for 4 we said add 1 to it. So then after this was our current number, this became my current number in the second call to this while loop. What that translates into code is, I will just increment my current number because this is consecutive. So plus 1, then plus 1, then plus 1 and plus 1 and so on. And at the end of this while loop, I will be left with my final sequence. In this case, it was 3. Now, please note that there might be not just one sequence in your input. There can be many sequences. But let's think back to our problem statement again. We have to find the longest sequence because we want to find the maximum gap, and then we will just multiply to get an area, which is the maximum area which we are looking for. That's why what we will do is we will keep a track of final consecutive sequence. It will be 0 at the start. After we find a sequence, we will say this sequence is the max between your current sequence that you are able to find and your maximum final statement that you keep track of. So it will be kind of a tracker to find the maximum in the entire input that you have. And once you find it, we will just return it at the end of this function. So we will just say find it and then return it. Now what we did here was, this was running in time complexity big O of n, and for each loop we are running another while loop. So we go through this element, pick this element, we go through the entire span of the input array for this element as well. In 2 loops, what we can also do is optimize this inner while loop a bit more, and we will not always call this while loop, but only when certain condition is met. And let's say that condition looks something like this. If you have your input here as 3, 4, 5, what we did was we put everything in a set at the start. So we said tracker set is new set of your input. So whatever your input was there, we put it in a set. And when you were at this element, let's say this was your current number. If in the set this current element minus 1, which was 3. Now in our case, this 3 already existed, which would mean that during the previous iteration, when this was our current number, you would have done plus 1 here and then incremented the number. So from 3 you would have come to 4. So the condition that was satisfied was that when you were at this number, if you do minus 1, whatever previous number that you get, which is 3, if that already existed in set, that means this is not the start of sequence. You have already traced the sequence from some other iteration, which was the previous iteration in this case, which means that we are just redoing it again and again. Now we can get around this by just putting a check that will look something like this. So if my tracker set dot has my previous number, the previous number is represented by nums of I minus 1, then it will have meant that if this minus 1 is already in my set, that means I already traced this before and it is not the starting element in my sequence, then I'm just repeating it if it exists. And I don't want to repeat, so I will say if it doesn't exist in the set, only then you do all this logic that we are doing here. Only if it is not there in the set. And this will reduce our time complexity and bring it to big O of n, because this runs in big O of n, this runs in big O of n also, but not through the entire input that you receive. This is now not doing repeated checks, because we said only if it is the start of the sequence, then only you do this in a loop. So now it is going to be big O of n plus big O of n, that gives us time complexity of big O of n. And this loop is going to give us time complexity of big O of n overall. And this basically means that this function call is of time complexity big O of n. And what we will now do is, we will say that this one is going to call find the longest consecutive sequence, and this one with vertical bars removed is going to call this longest consecutive sequence. We are going to find the sequence and then just multiply the sequence and add 1 to this before we multiply, because we said the gap that gets created is bigger than the sequence that we found. So if the gap was between these three elements, the actual gap was created because there were elements on both sides. So it is like 1, 2, 3, 4. And that's pretty much it in terms of our solution. This should give us the maximum whole area after the bars are removed. And this also takes this constraint into consideration, that this maximum vertical bars and horizontal bars might not intersect. And we can proceed with this constraint for now, because this usually gets asked in time-bound interview questions, and in that it's fine to assume this, because if you try to build the more complex solution, we will have to find the bars, the biggest gaps that we find, and these gaps have to also intersect, and we will have to put some checks here after we find these gaps. So we just keep finding the gaps and then we try to see if the gaps intersect. That we are not going to be covering in this scope. This scope is purely to build the base solution that we are looking for. And in terms of time complexity now, this one is going to take time complexity of big O of x, because x is the length of the horizontal bars removed, and this second one is going to be big O of y, because y is the time complexity of the associated with this vertical bars, saying that y input was linked to our vertical bars. And this in turn gives us the time complexity overall one as something like this, which is big O of x plus big O of y. That's the time complexity. And similarly, the space complexity will also be big O of x plus big O of y, because the space that is going to be used in worst case is basically here, wherein you put everything in your set. So in worst case, you can have all unique elements in your set, and that matches the length of your nums array. So it becomes big O of n. And in our case, we had y as the length of our vertical bars. So in that case, it becomes big O of y. And for horizontal bars, it was x, the length. So it becomes big O of x. So the total space complexity is big O of x plus big O of y. And this is not using any space. We just compute the result and return it. And that's pretty much it. Thank you for watching. Please like and subscribe. Bye.